Friends, let us discuss with nitrines. Nitrines are the reaction intermediates which are formed in the reactions like that of carboketones, carbanions, and carbenes. There is some similarity in carbenes and nitrines. Yes, definitely. Carbenes are electron deficient neutral carbon. Here, nitrines are the nitrogen analogues of carbenes, means they are electron deficient nitrogen and neutral in nature. Are neutral electron deficient nitrogens or nitrines. They are also very reactive, like that of carbenes, and it is very difficult to isolate these nitrines under ordinary conditions. However, ab initio calculation shows that nitrines are comparably stabler than carbenes. It is found that the difference between the energy of the carbenes and the nitrines is around 25 to 26 kilocalories per mole. Let us look into the structure of nitrines. Nitrines, as they are called, the nitrogen analogues, they are also called as azocarbenes. They are named as imines, imidazones, and also azenes. There has been a postulation in the year 1913. There is something called as nitrines which are formed during the course of the reaction. Till that time, nitrines were not known to anyone. Nitrines exist in either singlet state or triplet state like that of carbenes. In singlet state, both electrons occupy a single orbital and these electrons are in paired. They have opposite spins, or it is called as anti-parallel spins. If they exist in pair and in the single orbital, they are said to be in singlet state. In triplet state, the two electrons occupy two different orbitals and they have parallel spins. These are represented in this fashion as singlet, where the two electrons are occupying the same orbital. We are representing in this fashion. And when I represent one electron over here and another electron in the downside the nitrogen, then it is in triplet state. This is the representation of triplet state and the singlet state. If this is in singlet state, the nitrogen will be in sp2 hybrid form. As we know, if it is in sp2 hybrid form, it will have trigonal shape. If it exists in triplet state, the nitrogen will be in sp hybrid form. And this sp hybrid form, it has diagonal shape. Various factors that influences the stability are similar to that of the carbenes. Like we have seen in carbenes, the positive inductive effect, positive resonance effect, and positive hyperconjugative effect have increased the stability of nitrines. Positive inductive effect, because of the presence of electron donating group, it donates the electrons. As nitrines are electron deficient neutral carbon, it gains electrons, that's why it becomes more stable. Similar to that is the positive resonance effect or conjugation effect. And positive hyperconjugation effect also stabilizes the nitrines. Let us look into the generation methods of nitrines. Nitrines can be obtained by photolysis or thermolysis of azides. I take an azide and heat it hydrozoic acid NH, double bond N, double bond N. This nitrogen is electron rich and this nitrogen is electron deficient because it is bonded with four atoms, that is with double bond with nitrogen and double bond with a nitrogen. That lone pair of electrons are taken away. That's why this nitrogen becomes electron deficient. Here only two bonds are there and there is excess electrons. This excess electrons on the nitrogen moves towards the positive nitrogen and forms the double bond, and it gives rise to n triple bond n. Now there are three and here two, five bonds. It has become pentavalent. It becomes much more unstable. That's why to maintain its stability, one of the electrons moves towards this nitrogen, and this becomes electron rich. To satisfy this positive center, still which is positive, the bond between this nitrogen break and this moves towards this positive nitrogen, and I will get NH, that is a nitrene with the liberation of nitrogen. I take alkyl halide and treat with N3H. I'll get corresponding or N3 alkyl azides, which upon exposing towards UV light or heating, it decomposes to liberate nitrogen and generate nitrene. I'll take phosgene and treat with sodium alkoxide like sodium ethoxide. OET minus replace Cl minus. I'll get corresponding chloroformate. This chloroformate, the chlorine I treat with hydrozoic acid. It replaces and gives acidoformate. Acidoformate upon decomposition by thermal method or by photolytic method, it loses nitrogen and liberate ethoxycarbonyl nitrene. Second method of generation of nitrines is alpha elimination. Here the NH is flanked between two electron withdrawing groups, that is carbonyl over here and sulfonyl over here. Hence, it is acidic enough to donate this proton. If I use a base which is basic enough to accept the proton, it takes away the proton from here, and the electrons which are left on the nitrogen gives rise to an anion, an anionic nitrogen. When I heat it, the bond between nitrogen and oxygen breaks, and this will lose as sulfate and gives rise to ethoxycarbonyl nitrene. Third method is by oxidation reduction method. If I take cyanamide and treat with triphenyl iodide diacetate, I'll get corresponding nitrene. Dialkyl hydrazine 1,1 dialkyl or n, dialkyl hydrazine. When I oxidize it with lead tetraacetate, I get nitrene and the liberation of lead diacetate. Triethoxyphosphine I treat with nitrosophenyl. The electrons over here forms bond with oxygen, and it has to maintain its divalency. That's why the pi electrons moves towards nitrogen, As the electrons are shared with oxygen, phosphorus gain deficiency of electrons. And as electrons are taken into the nitrogen, nitrogen gets electron richness. To satisfy the positive center, the nitrogen oxygen bond breaks and electrons moves towards phosphorus. And phosphorus oxide is formed and the bond has broken and a phenyl nitrene got generated. The enormous ability of phosphorus to form bond with oxygen is the driving force for this reaction. These are the three important methods for the generation of nitranes. Next, let us deal with the reactions of nitranes in the coming presentation. Till then, have a nice day. Thank you.